Good evening, everyone. My name is Matt Brown, and I've been at Ground Cover for 2 whole weeks. As Chris mentioned, I've been in the Kubernetes security space for quite a while, so this is a bit different for me. But when it came to the Kubernetes security space, I have been dealing with eBPF agents, and so it really just made it a natural shift to go over to Ground Cover. And although I don't know as much about, say, APM or telemetry, it's something that still overlaps with what I've done before, so I've definitely taken the opportunity to get up to speed. So if I get anything wrong, forgive me. And as far as what I'm going to talk about, it's actually kind of the first point that I care most about, which is telemetry aware. When it comes to the AI agents interacting with Slack and being elsewhere in your other tools, it's basically the easy button. We have agent mode, which are a series of AI agents that you can be running on our platform. And so when you think about telemetry, there is a ton of data, whether it's logs, metrics, or traces. And the ability for having an agent to decipher what's happening and what you care about, it's essentially like, how many people have played like a red team capture the flag? Yeah. So if you've ever done that, it's quite hard. And it's designed to take hours and hours of work. And when you look at the volume of telemetry, essentially it becomes the same thing. I'm going to show you a demo. And part of the demo is you're going to see how hard it is to figure out what's wrong. I actually have a lot of it scripted, and unfortunately things change. And it's just really hard to figure it out. And that's where agent mode and its ability to allow you to interact with it, specifically in your native tools like Slack, really helps you out. So how many people are familiar with open telemetry? A few people. So open telemetry is an open standard. It's a CNCF graduated project, and it's designed to be a uniform series of SDKs, a uniform standard to collect your logs, metrics, or traces. And primarily it's also designed so that it's not vendor agnostic. If you build applications that leverage open telemetry, you're able to effectively monitor those applications. You no longer need a vendor. So how does it actually get collected? Well, an easy way you can do it, as you can see here, it's a little bit hard to see, but if I have a Node.js application, if I have a Python application with a fast API, the key thing for each of these, if I want to instrument the basics of OTel, would be that I actually don't have to make any code changes. And it is really going to give me those same 3 signals in each of these languages. In fact, there's more than a handful of languages that support this zero instrumentation technology. And these are all going to be auto-tagged. They're going to give you a ton of information right out of the box. Now that's great, but there's actually already one sort of what I would describe as a deficiency there. If you were to take this zero instrumentation approach, you would think it'd be easy, right? Would anyone think that you'd get all the data possible and you'd leverage something to the fullest extent if you took that easy button? I don't think so. I see some shakes of the head. And so you're actually missing the full value of OpenTelemetry if you just use the zero instrumentation. But again, it's easy and it provides you quite a bit of value over obviously doing nothing or using some of the kind of more previous technologies we use like Prometheus and such. But what's the reality in terms of what you can actually instrument? So these serve as 4 separate examples of places where OTel, especially zero instrumentation OpenTelemetry, would be fully impossible. So the first is, I mentioned that there are a handful of languages that support OpenTelemetry zero instrumentation, but if you're developing Rust applications or an assortment of other applications. So it's not just like legacy applications are having this issue. Rust is super modern. People are using it to write applications, and it doesn't have an OpenTelemetry zero instrumentation. So if you look back a few years ago, you had Go with the same issue. I assume Rust is going to have some sort of support. But again, using that zero instrumentation approach, you don't have that advantage. And you're going to have to do a lot of instrumentation to get the full value. Now you can also imagine that you're going to have applications in your environment that just predate OTel. These are older applications, there's nothing wrong with them. They just were written a while ago, and they don't have access to OTel at this point. And if you want to instrument an observability program, then you're kind of out of luck on those ones. Now the other is that, as I mentioned from the security industry, I worked for a company that did managed Falco, which is the intrusion detection standard for Kubernetes. But this is a tool that you don't control. You can't instrument this application. Now it does provide metrics that are helpful, which are Prometheus metrics. So when you install Falco, pretty much instantaneously you can figure out whether it's performing or not. And that's one of the main things that you care about with a lot of applications, whether it's running. I care about whether it's performing and sucking up a lot of memory, whether it's greedy in terms of CPU. All of that's available out of the box. But you're not getting any metric, you're not getting any traces, you're not getting any logs. Now this might not be an exact example where you need traces, but you can obviously imagine there's going to be quite a few applications that are outside of your control that you would like to have OTel for, which you can't get. And then finally, there is just the fact that in Kubernetes, you have applications that simply crash or don't run. So in this case, you don't have any data. No matter what the telemetry you're expecting to collect, it's literally just not there. It's quite simple. You have a container that fires up and it's out of memory. You're kind of SOL there. It doesn't provide any relevant telemetry. You're hitting a new class of diagnoses that you have to run to figure out why something's not running. It's no longer related to the performance of your application. The telemetry there to describe why a certain service is not reaching another, it's just literally not running. And even when the instrumentation is perfect, so you have OTel everywhere, you still have a lot of other trade-offs that you can consider. And Chris mentioned some of the advantages of a tool like ground cover. But other things to consider would be cardinality, which means the sort of the depth of data that you're going to provide. So if you look at things at the user level, you start to get almost an infinite number or infinite increase in telemetry. And if you're looking at sampling or dropping, especially now when you're starting to do that with AI especially, you're losing a lot of data and you're unable to really focus on what matters. And so that's where eBPF closes the gap. As Chris mentioned, I did join ground cover because of the eBPF agent capabilities. So when you now look and zoom out or go back to the three applications that I mentioned, your first would be that pricing application, which is a Rust application. So you don't have to do anything. You essentially have zero instrumentation as well. It's an eBPF agent. You literally don't have to rely on that zero instrumentation OTel. You're no longer dependent on that. And then you have your legacy app. So again, zero code changes. You don't have to do anything for that. eBPF is giving you everything. You have your Falco or other application that's out of your control. And this is especially a good example where something, an eBPF agent, is really going to help you ensure that you have the full visibility into logs, metrics, traces. Now, none of this is a replacement for OTel. There are actually kind of a whole new class of vendors that are rising up that are, say, instead of requiring a Datadog SDK, they support OTel, and all they ask you to do is instrument everything with OTel, and they'll figure out the data storage, and they'll figure out the agent mode on top of that. There's nothing wrong with that, but I think it's like this is just three simple examples where you don't get any visibility if you're going to rely on the OTel standard. This one might be a little bit tough to see, but it's basically it is the architecture of ground cover. Now, I will say that there are other technologies arising that are a bit similar with the bring your own cloud, but I really think the importance here is that you have the eBPF sensor and you have this is hard to see as well, you have the Kubernetes, what we call Kubernetes metadata enrichment. So it tells you when you have something or a finding from a specific entity or container that you understand the Kubernetes context that's there. And then you're also able to bring in your standard OTel data, which is absolutely necessary. And then you're able to bring in a ton of other custom metrics. Maybe you care about data that can flow through Fluentbit. You care about AWS data. You care about any number of other things like managed Redis data. All of that can flow in through custom collectors. And the advantage with a solution like ground cover is it's all bring your own cloud. You host everything. So you literally have nothing to worry about in terms of data leaving your premises. And the advantage too is that you can collect as much data as you want. The pricing is transparent based on the cloud provider. All right. So again, now that we have all this telemetry, so again, we have metrics that tell us whether our applications are working. We have traces that can tell us where you have latency or problems from user experience. And you have logs, an infinite number of logs that will tell you, based on those metrics and traces, what's actually wrong with your application. So what agent mode allows you to do is reason over your telemetry. So we've built agent mode ourselves, not as an MCP server where you have to digest everything. Now you can use an MCP server with ground cover, but it's actually something that's integrated on top, and you simply provide the API key or the key you need for an LLM, say like Claude. So the nice thing there, again, super transparent in the pricing. So we're not going to charge you kind of an unpredictable credit amount based on the amount of reasoning that we're doing. We're providing you transparent pricing where you control it based on where you're running, and that would run through, in our case, through Bedrock. Now, obviously, then it's going to allow you to correlate in plain language. In fact, you don't really have to ask it a lot. You care about why something's not working, you ask it, why is it not working? And that's going to give you the answer that you're looking for. And again, in the demo, I'll show you a little bit about how this capture the flag scenario literally gets compressed to figuring out the answer in just a matter of 30 seconds or so. And it acts through your own tools. So I'm going to highlight primarily Slack, but you also have ticketing integrations, which I'll show, into a tool like Linear. So for instance, if you discover an issue, the agent mode is going to be able to diagnose what's happening based on understanding telemetry. In fact, can figure out then where code is going to be needed to be changed. And then it can also interact with something like Cursor. So if you actually wanted to, say, issue a GitHub pull request, Cursor would be a good way to do that. So you provide Cursor the full telemetry and the full communication, and Cursor would be able to spin something up and produce that GitHub pull request. And I assume, how many people are using Claude or Cursor? I assume it's everyone. So it's pretty basic. It should be pretty easy for you to understand. So just before I get into the demo, follow sort of these 4 steps as I go through each scenario. I'm going to run through a few scenarios of where there is a problem. So we'll find a symptom. And that symptom will come from ground cover telling us what's wrong. And that could be slow checkout. This is all around an e-commerce application. It could be high latency on an AI response. So you can imagine you have a chatbot sitting there and people have questions and they get delays in that. What's the cause of that? And the first cause typically is something very simple. You have errors. You have P95, which is that 5% at the edge are experiencing a high level of latency. This is, I mean, it's the obvious answer, but it really doesn't tell you what the root cause is. I have this listed as to be determined because my environment's a little bit crazy. It kind of changes constantly. So in fact, what I've scripted doesn't always work. So as we go through, I'm gonna try to kind of point and click and figure things out. Go through logs, metrics, and traces. Again, play capture the flag. And I'll run the agent by the side and we'll have already figured it out before I'm even like 30 seconds into trying to figure this out on my own. That's the easy button. And it's not, I want to say it's not particularly interesting for you guys to see, except you can see the results and it works and it's cool that way. But I wanted to show you what it's reasoning over and sort of what the mental math I have to do to figure out how to solve this. Any questions before I dive into the demo? All right, let me change the sharing. Try to get rid of this Zoom. There we go. So here I'm kind of have a few different Slack channels. If I step away, they're conveniently organized based on the scenario that I'm discovering. So the first example you'll notice there would be AI errors. This is going to show us what I mentioned, AI latency with interacting with the chatbot. So obviously that's a poor user experience. Now you'll find out it doesn't necessarily mean anything's wrong per se. It just can mean we're not being efficient. You also see it's there called AZ cost. So this has to do with something that's actually very hard to discover without eBPF, or if you're familiar with what a service mesh is without a service mesh. And the AZ cost is really, really hard to diagnose. We also have checkout errors, which is a bit more of a basic finding. It's just not working. I want to figure out why. Confirmed orders is the one I usually can't get to work, but agent mode can usually figure it out. That one is one of the more interesting ones because it's one where things are technically working from end to end. It's all green, but something's actually not working in that environment. And then finally, we have slow payments. Again, high latency, we care about that. And that's an example. If I can get that one to work, I think it's the most difficult. That one will show how we can actually focus in on making code changes to fix things. So let me dive into AI errors. So does anyone want me to push investigate with agent here?
Yeah.
Okay. I'll let it do its thing. I'm pretty sure it'll figure out before I've done anything. So in this case, again, as I mentioned, this is looking at high latency here. In this case, it's a high P95. Again, when you want to look at the performance of applications and the speed with which the application is responding, if you were to take an average, like anything else mathematically, you would not get the true kind of experience. So it's that 5% where we care about. And it's because, for instance, a typical response might be 0.1 seconds, might be milliseconds, whereas a P95 shows up as 7 seconds. And obviously 7 seconds, it doesn't seem like a big deal, but I'm pretty sure everyone would get annoyed. if you had to wait for something for 7 seconds on the internet, that is. So in this case, how do I get started? Well, if I come in here, I'm going to go through the workload. And if you're not as familiar with Kubernetes, I have a container running. The workload is what's managing that container. So it's really just applying the configuration. That's it. So I'm going to go ahead and jump in. Now I can start to look at things like logs. There's nothing wrong there. You can look at network data. There's nothing wrong there. A lot of things are not going to be wrong. So let me go ahead and go into my APIs. My only API here is the chat API. And this is where I'm going to have obviously latency. Again, if you're familiar with, say, with Kubernetes, the health endpoint there is just to make sure the pod is running successfully. It has nothing to do with the actual functionality or running application. So I will click into that. And what I can start to see over here is a category for latency. So let me go ahead and put that in there. And actually, what I'm going to do, I'm going to go back here. I'm also going to put agent mode in here. What's cool is you can do it right in here. And something that's way nicer is you can add in skills here. So you can manage a list of your own skills. So in a real world situation, you could picture where you have an organization you're working with. You have a ton of different applications running. Each of those application teams has their own sort of tribal knowledge of what is important, what matters, what could go wrong, what's expected that's kind of weird or not weird. And that's what you can add in as a skill. And obviously then you could use something like Claude to parse out the repo and look for some of those things that you would expect. Or as you start to discover anomalies and you notice something is wrong, then you can write a skill based on that directly through agent mode here. So it really kind of closes the loop there. So I'll go ahead and run it there. So if I start to look at some of these, I care about the chatbot service. And I can look here. And what I might see is maybe it's dependent on the model I used. So here I used Haiku and I got high latency. Again, I don't know if the data fidelity here, or if I come in here and I use Sonnet here, all these requests have succeeded. So in this case, what I might be looking for is the model that I'm using, or in fact the text that I'm using. So you'll notice here, let me go back and I'll choose my OpenTelemetry data because I did add that in. And I'll add that in. And I can see exactly what's happening here. And you notice that the chat message there is in plain text. So that's also the advantage of eBPF, where you can get fully plain text of any encrypted communication based on its ability to connect into the application or in the kernel by something called uprobes, if you're familiar with that. If not, I encourage you to look up eBPF and some of these fun terms that I use. So I don't really understand what's happening here by clicking through. I could probably spend another hour trying to figure out what's going on. But let's see what agent mode figured out. Oh, it looks like it's still going. Let me pull this up. And so in this case, I can see that there are two compounding effects. So I have some kind of pod timeout, and I have Claude Sonnet being invoked with this many tokens, and it's coming up with this response times. And then I have another intermittent slowness, which appears to occur. So all three of these different events that I can then go and investigate and try to figure out what's going on, what's problematic, it's all been presented to me in 5 minutes ago. So it looks like I've taken a little long to go through this investigation, but those 5 minutes ago meant that it resolved the issue or diagnosed the issue in just 10 to 20 seconds. So let me jump into another one here. This one's a bit interesting. So it's actually very easy for me to solve, kind of based on my mindset. So in this case, I have alerts across zones. So again, I'll click investigate, but I'll come in here. All this is saying is that there's a lot of cross AZ traffic. So obviously with something like AWS, you have different zones that you can have. And so by letting traffic cross AZ zones, you're increasing your costs. How could I figure this out? Well, I could look at VPC flow logs and I could kind of figure it out and see that there's a lot more cross AZ traffic. Or again, I could maybe look at my bill and see it's increased. Or if I do in fact have a service mesh, if you're familiar with Istio or Linkerd, you'd probably get a lot of this information already. But we'll assume none of that does not apply. So I can see in this case the specific workload again. So being more myself Kubernetes focused, I would pretty much immediately think that there's something wrong with this pod. So whenever something is not running or it's not connecting correctly, I would diagnose it down to the pod here. And it's actually quite easy if I come into the pod configuration and go in here. And again, if you're familiar with Kubernetes, I should see there, we have a node selector. So in this case, what's happening is this pod is trying to reach out to another availability zone, but it's forced to sit in its own availability zone. So the idea behind Kubernetes obviously is that you have sort of unlimited replication. Things are balanced correctly across tons of compute. And so if you force something to sit on a specific computer, then you're going to create problems almost certainly. So again, let me go back to agent mode. And so I figured it out there, a stale node selector. And of course, it might be able to tell, okay, this node selector only existed in the newest deployment. So you could figure out that some sort of issue was happening in the most recent deployment that a developer pushed, or it might be something from previous. But it's a super simple change. And you could say run that through cursor or put it into a linear ticket. And you would be able to see the results go into action and fix things very quickly. And how much time do I have left? I think
5 minutes.
5 minutes. Okay. I'm not going to go through all of these. But again, I can just pull up investigate with an agent. I don't know what's going on here. Check out requests are failing. Payment errors. I think this one has to do with like a Stripe endpoint not working, for instance. It's one of the more simple ones, but it's a little bit hard to diagnose because you have to look at a cascade of traces and click in and figure that out. It's probably something that you would mostly rely on eBPF to tell you, because your distributed tracing won't necessarily tell you if an endpoint out of your control is having issues. And I can see that. And it'll come up and I'll let that run there. Confirmed orders, again, a very interesting one. I'll go ahead and click investigate. Investigate. So again, confirmed orders means that I sort of have this shadow orders that aren't succeeding. So everything is green, and in fact, that's probably one of the most challenging things to resolve. But each of these cases, agent mode is able to resolve them. And I can click in here. Let me see if I can go back and get. And so it's running through each of these. Again, should take about a minute to resolve. But yeah, that's I'll wrap up my presentation there and open up to any questions people might have.